Okay, welcome back. We're doing a quick update on where we're at with the two-wheeler, the self-balancing two-wheeler that I've been working on, and it's been a while since the last update. It's been about 2 weeks. A lot has happened. I've broken things, I've fixed things, I've learned lots of different things about what I should have done better and differently, and so I wanted to give you an update today. I've made some decisions about the future of what I'm going to do with this little robot as well, but let's have a look at it. So let's go to the robot. This is my little workbench that I was, I think, showing you before. I've purchased myself a little good oscilloscope, actually, Siglent SDS824X HD. It's really nice. Been playing with that. It goes with the rest of the instruments I have here, and I've got my soldering station and the rest of the setup. But the robot itself, obviously, is here. Since we last spoke, I've blown up an ESP32S3 and 2 motor drivers, which was pretty disappointing, if I'm honest. What I did was I plugged the S3 into the female headers incorrectly and obviously put a higher voltage on a logic pin, or something happened where it wasn't happy. It wasn't obviously broken, but it got very hot very quickly, so that told me that it was broken. And then I replaced that, so I waited for a replacement for that. When that finally came, I plugged it in, and I'd been updating the firmware while I was waiting for the part and testing it on a C3 actually. And when I plugged the new S3 in and got it going and tested, I found out that the 2 motor drivers were also dead. So that was disappointing. The really disappointing part about that was I'd made a decision to solder the motor drivers directly to the perf board. In hindsight, a big mistake, because literally just about everything, power, signals from the S3, the only thing I think that isn't connected to the motor drivers is probably the IMU, which is only connected to the S3 for I2C, but basically everything connects to this, so it was a major pain to have to pull that off and fix those two. What I've done is I've mounted those on female headers now, as you can see, so if I have any issues with those motor driver parts in the future, I can just pull those out and replace them without having to touch the rest of the board. So lesson learned. I did take the opportunity to clean up the wiring on the board and the soldering, and so it took me a day or so to get all that fixed and back up and running, but that was quite a unexpected exercise. The other bit of work that I've done is I've built myself a little Android app. I used Flutter here, so apologies for the refresh mismatch there between the camera and my phone. But basically I've got some status indicators at the top for what's happening with the robot and the battery level, a little D-pad to go forward and back and turn left and right, and also pause, which means just stop and balance in place. And then I've got arm and connect. Connect connects to Bluetooth and then toggles to disconnect. Does some safety checks on the robot, and then if it's able to, it arms everything and it leaves the motors off. But actually, does it leave the motors off? No, it arms the motors, it turns the motors on. And so this is my control panel, and then while I was tuning this thing, I was finding that I was connecting over USB-C to a serial logger, and I was looking at and inspecting serial output during runs or after runs. And so the iteration loop of test a PID loop, or test certain PID gains and then visualize what that did, was too slow. And so I extended the app just to be able to in real time update both all of the PID gains and also a manual trim, and then apply that immediately. So the apply now button just updates the running bot with those values in memory, and then if I want to persist that and I'm happy with that, I can save to preferences, which saves that to flash on the S3. So that works really nicely. The other functions I have down here are calibrate, log, and dump. Calibrate lets me calibrate the IMU for vertical position. The log lets me start and stop logging, and then dump allows me to dump over serial anything that's been logged to the flash on the S3. And so what a workflow might be, I connect, run, come over here, hit log, run the bot for a while, which logs locally, stop logging, disarm, disconnect, and then come back here, connect this to my computer, and then over serial, just go back here and hit dump, and then have have all the data just printed to serial, and then I can inspect it on my laptop and do plotting and visualizations and whatever else. So this has been a little godsend, this app. So I used Flutter, super easy to build with. The widgets are really easy to use. There's nothing sophisticated here, but it's been super useful and highly recommended if anyone else is thinking of doing anything like this. Now on the bot itself, I've got it to a point where it's tuned well enough to balance in place for 10 to 20 minutes at a time. It can turn left and right and move forward and backwards. Forward and backwards just sets basically a tilt bias, and then that currently is being fought by the PID loop, so it's not complete. Turn left and right works reasonably well. I still have some work to do on damping. I mean, if you look at my PID values here, let's turn the whole thing on, shall we? So we'll turn the bot on. We'll come back to our app. We will connect, which should connect to the bot. So you can see it's connected, tune values are loaded. I've got 16 volts on my battery. I won't arm yet. I'll go to tune, and these are all the current tune values. So I'm using not that this matters, but a gain of 5 for my P gain, 20 for I, and 0.05 for D. So I'm not doing much damping there, as you can see. That's, yeah, I need to look at that. But I've played with this quite a bit, and I'm able to play around and get that balancing. So what I would normally do here now is I'd hit arm. Now if I hit arm in with the bot in this position, it won't allow me. It'll say arm denied, and that's a safety mechanism to stop the bot from being armed in positions that don't make sense. So if I wanted to arm, what I would need to do is have the bot vertical. I basically just use the IMU to tell me if I'm tilted more than, I think it's 20 degrees or 15 degrees. I think it's 20 degrees. And if I am, then I don't allow arm. So what I might do is set up the camera so that we can have a look at it. So I'll hit arm on the bot and then just see what the bot wants to do. See if it can find a balance point. It doesn't look particularly happy. It looks like it's trying to move forward rather than back. Okay, all right. So it's sort of found a balance point there. That's not too bad. And we now have our bot just sitting there and balancing. It will happily balance here for, long periods of time. Until I either get a Bluetooth disconnect on the app, in which case I disarm and turn everything off just for safety again, or until it runs out of battery or something else happens. It does still have an issue where it does occasionally just run away, which could be related to the I gain that I'm using. I'm not entirely sure. But if I try and turn left and right, it's sort of, it's a bit janky. But I've got turn. I can go forward. I can go backwards. It's running away here. And so you can sort of just see that's sort of functioning reasonably well. I'm trying to hold too many things, phone and camera. So anyway, that's a little update on where we're at with the bot. Now, if I was just to disconnect, it would just disarm automatically, which I'll do. Okay, disconnect. Okay, disarm, fell over, and it's pretty happy. So let's set that aside. So where I'm at, I guess, is I'm thinking about what I want to do with the two-wheeler moving forward. It's been a lot of fun. I've learned a lot. It's got me back into electronics, which I haven't done for a while. I've done a lot of programming in my life and software development, so the microcontroller side wasn't too hard for me. And I did study microcontrollers at uni many years ago when we were looking at 8-bit PICs, so that was a long time ago. But I won't tell you how old I am, but you could probably guess. Anyway, and so it's been fun to get back into that. But the two-wheeler is very basic and simple. It does introduce a whole bunch of control concepts though, like PID loops, and it has been fun to try different ways of driving the stepper motors. And so I've used ISRs, I've used timers on the ESP32, I've used the RMT peripheral, which didn't turn out to be the right way to go. I've used all sorts of different things. What I've ended up using is a phase accumulator architecture using a 200 hertz control loop. And I'm using I think it's a 10 kilohertz, I think it's 10 kilohertz stepper timer. So that's what drives and builds the stepper pulses that I send to the stepper drivers, the motor drivers. And so that phase accumulator allows me to manage changing the frequency of those pulses, and it works quite nicely. So I've done that even though I'm running a pretty high frequency timer there. It's 10, or I think it might be a 20 kilohertz. Let's call it a 10 kilohertz timer loop there, or timer rather for generating stepper pulses, and a 200 hertz control loop. So it's all been good, and I've enjoyed that. And it's a pretty low cost bot. I think it's probably cost me about probably $120 or something. I'm not sure. Let's say $150 for the BOM. And I didn't have to buy any other components to manage it remotely, because I could just do the BLE app, the Android app on my phone. So that's been good. I think what I'm going to do though moving forward is build a more stable platform, because what I wanted to originally do with this was have a monocular architecture, so a single camera front facing, not just for FPV style video, but I was going to use that to start to do some lightweight computer vision type tasks. I was even going to look at doing some simple SLAM experiments, and that obviously requires a beefier compute board, and I was going to look at trying to either run that on a Pi that I would attach to the bot, or even probably a more powerful compute platform in the future. And the two-wheeler's been great. It's still not tuned properly, as you can see. It's a lot better than it was. And I'll keep experimenting with that, and I intend to keep making that more robust. But in parallel, what I'm going to do, I think, is build a four-wheeler, and that will give me a stable platform. I can make it a sort of 400 by 300 millimeter chassis. I can put bigger batteries on it. I can have a 5,000 milliamp hour 6S battery and standardize on like a 24 volt power architecture. And then I can always stack up. So I can have, batteries on the bottom. I would have four motors driving four wheels independently. The idea would be to build towards a four-wheel drive, four-wheel steer type rover type platform, and then eventually I could have other compute platforms that I just stack on top and talk over UART or whatever. So that's the plan, I think, now, is to continue to tweak this and use this as a learning platform for control and get this more robust. So you hopefully will see a couple more videos, or at least one more video, when I kind of get the bot to that point. But then I'm going to start to, I think, prototype or bench test out just a single corner of that four-wheeler. And so I'm looking at speccing some brushed motors and get a controller and get, basically put the electronics together just for a single, like a quarter of the bot, and then start to test that out and still use ESP32 as my microcontroller platform. I've heard people call it a microcontroller. I've heard people call it a system on a chip. Whatever the case, I'll use it as the main brains for actuation and for control. And then above that and beyond that, I'll do probably another compute platform. Like I'll put a Pi 5, or I might go crazy and put a Jetson on there or something. I've been looking at the Jetson Nano Supers. They look pretty cool. Because some of what I want to do is CUDA accelerated, and you can't do that unless you're in the NVIDIA ecosystem, and so a Jetson would be pretty cool to run on that, which I just can't really realistically do with battery and power and stability on the two-wheeler. So that's the plan. That's where we're at with the build. Thanks for hanging around for 10 or 15 minutes, or however long this video has been, listening in. Like it if you like it. Like the video. I would love some feedback on this. Subscribe if you're interested in seeing more updates. I will post another update probably on the two-wheeler, and then I will probably be building and starting to post weekly or fortnightly updates on the four-wheeler, as well as I kind of build that out and think about how to do that. And that should be a much longer term platform, like I said, with some computer vision and SLAM and some other experiments that I want to run on top of there. So thanks again, and hope to see you in the next one.